In the vast, endless darkness of the universe, stars are the beacons of light that define the cosmic landscape. They form from swirling clouds of gas, ignite in nuclear fusion, and live for millions or even billions of years. But what if some stars defy the very laws of physics? What if some shouldn't exist at all? Astronomers have spent centuries refining our understanding of stellar evolution, but every now and then they stumble upon a celestial anomaly, stars that break the rules, stars that should have burned out long ago, or ones that defy conventional formation theories. These objects challenge everything we think we know about the cosmos, forcing scientists to rethink their models and push the boundaries of astrophysics. One such enigma is Methuselah's star, officially known as HD 140283. This seemingly ordinary-looking star is anything but typical. Located about 200 light-years away from Earth, Methuselah's star has puzzled scientists for decades because calculations suggest it is older than the universe itself. That's right. While the universe is estimated to be about 13.8 billion years old, early estimates for this star's age placed it at a staggering 14.5 billion years. This paradox threw astrophysicists into a frenzy, forcing them to reconsider their measurements, refine stellar models, and even question our understanding of the universe's true age. How is this possible? One explanation lies in the uncertainty of stellar age estimates. While newer models have slightly revised Methuselah's age down to around 13.7 billion years, just within the age of the universe, it remains one of the oldest stars ever discovered. Its composition tells a story of a time when the universe was young and had not yet formed many heavy elements. Unlike our Sun, which contains elements forged in previous generations of stars, Methuselah's star is mostly hydrogen and helium, with very little metal content. This suggests it formed at a time when the universe was still in its infancy. But Methuselah's star is just the beginning. There are other stars that exist in places where they shouldn't or defy physics in ways that leave scientists scratching their heads. Take, for example, the so-called impossible stars found in the early universe. Observations from the James Webb Space Telescope have revealed massive, fully formed galaxies existing just a few 100 million years after the Big Bang, an era where such structures should not have had time to form. Similarly, there are stars in our own galaxy that seem too metal-rich for their location. The galactic halo, the vast, diffuse cloud of stars surrounding the Milky Way, should be composed mostly of ancient, metal-poor stars. Yet astronomers have detected stars in the halo with surprisingly high metal content, suggesting that they may have originated elsewhere and were somehow flung into this region. Could they be remnants of long-lost galaxies that were absorbed by the Milky Way? Another mystery lies in a class of objects known as Thorne-Zitoch objects. These bizarre entities blur the line between stars and neutron stars. Theoretically, a Thorne-Zitoch object forms when a massive star engulfs a neutron star, creating a hybrid system where the neutron star sits at the core, sustaining the outer layers in a strange and poorly understood process. Only a few candidates for these objects have been found, but if they exist, they challenge our understanding of how stars evolve and what happens at the extreme ends of stellar physics. Then there are the so-called dark stars, theoretical objects that might have formed in the early universe. Unlike ordinary stars which shine due to nuclear fusion, dark stars might have been powered by dark matter annihilation. If such stars ever existed, they would represent an entirely new way for matter to generate energy, opening up possibilities for exotic physics beyond our current understanding. And what about the ultra-long-lived stars? Conventional models suggest that stars like red dwarfs can burn for trillions of years, far longer than the current age of the universe. This means that the smallest and coolest stars formed at the dawn of time may still be shining billions of years from now. But could there be other types of stars that exist even longer, fueled by unknown processes? As we peer deeper into the universe with ever more powerful telescopes, the number of unexplained stellar anomalies continues to grow. Some of these stars may force us to rewrite the rules of physics, while others may simply reveal gaps in our current models. But one thing is certain: every time we think we understand the cosmos, the universe finds a way to surprise us. One of the most perplexing stellar mysteries is the existence of stars in environments where they should have never formed. Consider HE 0107-5240, a star discovered in the Milky Way's halo with an incredibly low metal content. According to standard astrophysical models, the first stars to form after the Big Bang, known as population 3 stars, should have been composed almost entirely of hydrogen and helium, with virtually no heavier elements. These early giants were believed to burn out quickly, enriching the cosmos with metals that later generations of stars incorporated. Yet HE 0107-5240 appears to be a relic from this primordial era, with an iron content 200,000 times lower than that of the Sun. This means it may have formed directly from the material left behind by the universe's first stars, an extraordinary find that challenges our assumptions about stellar evolution. If such stars exist in our galaxy today, it raises a profound question. Could we still find an unburned population 3 star, a true first-generation object that has somehow survived for over 13 billion years? Even more baffling are rogue stars, sometimes called hypervelocity stars. These are stars moving through the galaxy at speeds that defy conventional gravitational interactions. Some of these objects travel so fast, several million kilometers per hour, that they are on a trajectory to escape the Milky Way entirely. But where do they come from? One likely explanation involves interactions with a supermassive black hole at the center of our galaxy. If a binary star system drifts too close to the black hole, one star may be captured while the other is ejected at extreme speeds. These events create hypervelocity stars that now race through intergalactic space, destined to wander the void between galaxies. But not all rogue stars originate from black hole interactions. Some may be the remnants of galactic collisions, stripped away from their home galaxies and flung into the cosmos like celestial refugees. The study of these objects is crucial because they carry with them the chemical fingerprints of their origins, offering clues about the violent history of galaxy mergers. And then there are the zombie stars, stars that have already exploded in supernovae but somehow manage to persist. Normally, when a star reaches the end of its life cycle and undergoes a supernova explosion, it either collapses into a neutron star or a black hole, or it disperses into space entirely. But astronomers have discovered cases where a star appears to have survived its own destruction. Take IPTF 14 HLS, a star that was observed exploding in a supernova event in 2014. That would be unusual on its own, but records show that the same star had already exploded decades earlier in 1954. This should be impossible. A supernova is a one-time event. Once a star detonates, it doesn't recover. And yet, IPTF 14 HLS continued to brighten and dim repeatedly over several years, as if it were undergoing multiple explosions in slow motion. One possible explanation is that it is part of a rare class of pulsational pair instability supernovae, where the core undergoes cycles of extreme nuclear burning, shedding layers of its outer material over time rather than collapsing immediately. But if this theory is correct, IPTF 14 HLS is unlike anything ever seen before. Could there be other such undead stars lurking in the universe? Then there's a mystery that goes beyond physics into the realm of the unexplained. Tabby star. Officially named KIC 8462852, This star captured worldwide attention when astronomers noticed something unusual. It was dimming in an erratic and unpredictable way. Most stars exhibit periodic dips in brightness due to orbiting planets or natural fluctuations, but Tabby's star behaved differently. It would sometimes lose as much as 20% of its light, far too much for a planet to be responsible, and it never followed a consistent pattern. For a time, one of the more speculative explanations was the possibility of an alien megastructure, a massive orbiting construct built by an advanced civilization. While this idea captured the imagination of the public, scientists have since proposed more natural explanations, such as an enormous cloud of dust or fragmented comets obscuring the star. However, no theory has fully explained all of its unusual behavior, leaving Tabby's star one of the most enigmatic objects in the galaxy. As astronomers continue to scan the heavens, they keep finding more of these impossible stars, ones that exist in defiance of conventional wisdom. Whether it's a star that formed before it should have, one that moves faster than physics predicts, or one that somehow survived its own death, these cosmic anomalies remind us that the universe is far stranger than we ever imagined. Another baffling category of stars that shouldn't exist is the supermassive stars found in the early universe. According to our current understanding, the first generation of stars, population 3 stars, were likely much larger than modern stars, with some reaching hundreds of times the mass of the Sun. However, recent discoveries suggest that some early universe stars may have been even more massive than previously thought, pushing the limits of what physics allows. The James Webb Space Telescope has detected evidence of stars that could be thousands of times the mass of the Sun. These hypothetical objects, sometimes called supermassive primordial stars, would have burned incredibly hot and bright, living for only a few million years before collapsing into black holes. But if these stars truly existed, they might explain the origins of supermassive black holes, which remain one of the greatest mysteries in astronomy. How could such enormous black holes, millions or even billions of times the Sun's mass, have formed so early in cosmic history? If supermassive stars were their precursors, it could provide a missing link in our understanding of black hole formation. Then we have the mysterious class of stars known as magnetars. These highly magnetized neutron stars possess magnetic fields 1 trillion times stronger than Earth's. Such extreme forces can twist and break the star's crust, causing powerful bursts of X-rays and gamma rays that can be detected from thousands of light years away. But magnetars shouldn't exist in the numbers we observe. Only a small percentage of neutron stars should be able to generate such extreme magnetic fields, yet we seem to find them more frequently than models predict. What mechanism creates such powerful magnetism? And could there be even more extreme versions of magnetars waiting to be discovered? Perhaps even more astonishing are the stars that appear to be made of antimatter. In 2023, researchers using data from the Fermi Gamma Ray Space Telescope identified unusual signals that might originate from stars composed largely of antimatter. In theory, such objects, called antistars, should not exist in significant numbers because the universe is overwhelmingly made of normal matter. If antistars do exist, it raises profound questions about the early universe and whether antimatter-rich regions could have somehow survived after the Big Bang. Another category of strange stars includes blue stragglers, stars that appear far younger than they should be. Found in dense star clusters, these stars should have already burned out based on their estimated age. However, they shine brightly, as if they've been given a second life. The prevailing theory is that blue stragglers form when two stars collide or when one star cannibalizes material from a companion, rejuvenating itself in the process. But the exact mechanisms behind their formation are still debated, and the existence of these stars challenges our understanding of stellar life cycles. And then there are the stars that simply shouldn't shine at all. Some objects, known as black dwarfs, are theoretical remnants of long-dead stars that have cooled to the point where they no longer emit light. However, current models suggest that the universe is not yet old enough for black dwarfs to exist. It would take trillions of years for a white dwarf to cool into a true black dwarf, meaning none should exist. Yet some astronomers speculate that certain extremely faint and cold stellar remnants might already be hiding in the depths of space. As we explore the cosmos, we continue to find more of these impossible stars, each one challenging the boundaries of physics and our understanding of the universe. Are these anomalies simply rare cosmic accidents, or are they signs that we still have much to learn about the fundamental forces that shape the stars and galaxies around us? One thing is certain, the universe is far stranger than we ever imagined, and the more we look, the more we realize that some stars simply shouldn't exist, yet they do.